So today we're talking about odd divisions on squares and square grids specifically. And there's several reasons why you might want to make an odd division on a square. One of those reasons, and the most commonly used one for me, is because I'm trying to get a higher division grid. So I'm going for like 24, 48, 40, 80, 72, whatever the heck grid that I want. And I know that that number, while it is an even number, has a factor that's odd. And that's problematic if I want to be dividing by 2 as much as possible. So these odd divisions, we're talking 3, 5, 7, 11, stuff like that, are numbers that you can't just divide things in half to get. So other reasons why you might be going for an odd grid is maybe you're going for that grid specifically. Maybe you need thirds for something, or fifths or sevenths. Maybe you need slightly more than that. Maybe you need 10 or 14 or 22. So this is a way to get exactly the divisions that you want without cutting any edge off, without guessing, without iterating. And so I'm going to start today with sevenths and then go on to thirds. And I'm going to be using a universal method that you can use on any square grid. So that means not just the grids where we're treating the edges as grid lines. And we'll see that in the end. I'll do fifths on this grid. So because we are going for like full generalizability, I'm not going to say, oh, get another piece of paper with evenly spaced markings and line up the edge so that the corners are on opposing lines and then fold. That can be very useful for getting specific points on the edge of a paper. But I've found that the technique I'm going to teach, the crossing diagonals technique, is much more general and can be used even on those rotated grids. So, sevenths. What I'm going to do is start by saying, okay, 7 is equal to 4 plus 3. And so let's treat this bottom edge all the way from edge to edge as 4. And if that is 4 and we're counting from left to right, where is 3 on the top? Now the reason I picked 4 is because it's 2 times 2. So we're looking for a power of 2 and its remainder with respect to our target number of divisions. So we're looking for the highest power of 2 that is less than our target number. Subtract that power of 2 from the target to get our remaining number. And we know that 3 is going to be half and quarter. So let's find those with actual folds. I'm going to pinch here to form the half, and this is why I don't guess, because I'm off. I'll use blue for the actual measurements. And then bring our edge up to the halfway mark. Again, this is why we don't guess. And so now we have a measure of 4 and a measure of 3 on parallel lines. And so when I want to find my divisions, I'm going to cross the diagonals of these two lengths. So we've got the length of 4 the length of 3, they're parallel, and I'm going to cross their diagonals. Well, how can I find that? I'm going to fold it. And so no ruler required, we're just using the paper itself. And for today's demonstration, I'm going to fold these diagonals all the way through. But if I was doing this for my own grid, I would just pinch the area where I thought the diagonal from the other direction was going to come through. So, and conveniently, it doesn't go through my writing. So we've got our new diagonal in one direction, and then we need the diagonal in the other direction. Notice this is not the full diagonal, this is the diagonal on our measure of 3. So we're going to go from that measure of 3 to our lower corner. And again, if I was doing this for my own grid, I would not fold all the way through. I would just make a pinch at the intersection of the diagonals. But for today, for demonstration, I'm folding all the way through. And we'll get our second diagonal in place. And while we're here, I want to be very explicit about marking and saying this distance up here is 3. So we've got this 3 and that 4. Okay. So now we've got our intersection point, and that intersection point gives us the division between the top and the bottom, where there are 3 spaces on top and 4 spaces on the bottom. Cool, huh? So having the 3 on the top, this distance, corresponds to 3/7 vertically, and the 4 on the bottom corresponds to 4/7 vertically. So now how do we get the actual folds for the 7ths onto our paper now that we have our point? And this is effectively, if we're doing coordinate points, this would be 3/7, 4/7. So it's 3/7 over, and we know that because this is the main diagonal, and we know it's 3/7 from the top, so it also has to be 3/7 from the left edge. That's 4/7 up. So this point, if you notice, will work for a reference in both directions. And we can know that both because it's using the main diagonal, and also for another reason that I'll explain next week when I talk about using this method on triangle grids. So we need to make a division to get a fold line going all the way across the paper. And I'm going to pick the even number, the 4, to divide in half. So I'm going to bring my bottom edge up to my reference intersection. And I'm making sure to line up my corners with the edge of my paper, because when you're folding a line to a point, there's actually infinitely many ways to do that, and I want to do specifically the one that's parallel to the edge. So what do you get when you divide 4 in half? You get 2 and 2. So 2 is still an even number. I can keep dividing from there. So I'll bring my bottom edge up to the fold that I just made and bring it flat. And then, because of what I just said about bringing a line to a point, there's infinitely many ways to do that. I'm not going to reverse this fold and bring it up here immediately. What I'm going to do instead is say, okay, this whole distance is 7. This bottom one is 1. So if I bring the top edge down to this first line, that would be 6 divided by 2 is 3. And so for demonstration purposes, I'm going to keep my paper arranged in the same way. Usually I would rotate halfway around, so I'm folding away from myself. But I'll fold this top edge down to my division 1, and I'm going to mark these just on their edges so you can see where they are without interfering with the rest of the diagram. I'm going to bring it down to the number 1 line. Fold across. And you'll notice this goes exactly through my reference intersection. I'll just make sure to use my bone folder and crease that nice and hard before I open it back up. So we predicted that that would be 3, and indeed it went straight through our reference intersection. So now if I want to fold more, I can't divide the 3 in half, but I can divide these two in half, and now I would be folding line to line. So what I'm going to do, and it doesn't matter which of these two lines I change to mountain to do it, I'm going to choose the one closer to me because that's my habit, and bring it up as a mountain. So reversing the mountain valley assignment, bring it up to the line that I just folded. And for me, I'm going to reverse all of these creases to a neutral orientation anyways. So I don't care if I change one to mountain in the middle of folding these 7ths. And then now I have this 1 spacing below the 3 on top, and 1 plus 3 is 4. So I can bring my top edge to the fold that I just made. And you'll notice here that all of my math is adding numbers and seeing if things are even, and sometimes dividing by 2. This is elementary school math, and yet we're able to make any odd division that we want. The one thing that's slightly more is like knowing what 2 times 2 times 2 times 2 times 2 times whatever is. So knowing the powers of 2, being able to add and subtract, and being able to divide by 2. That's really all you need to do any odd division. So now I've got this new fold, and it's marking 2 spaces from the top. We can know that both because we said, okay, 3 plus 1 is 4, and 4 divided by 2 is 2. So then I can bring my top to that next fold. And get that squared away. And we have a question, does it work for dividing rectangular paper? Yes, this will divide any paper that you have, as long as your top and bottom edges are parallel and you have the relative counts, the relative distances for the top and the bottom. you can get these divisions. And I'll be showing next week how this works on triangle grids too. So what wouldn't necessarily work on rectangular paper is the division in the other direction. But because we have this diagonal running all the way through from corner to corner on the square, we know that this reference point is going to work in the other direction as well. And this side that was 3 is going to correspond to this side being 3. So I'm going to run through those same folds, but in the other direction and with rotation of the paper how I would normally fold it. So I'm going to bring the distance that's greater from the intersection, the 4, up to the intersection point. And this time we're not just doing line to point, because I have that fold line that's going straight through the intersection point. I'm actually bringing this point on the edge of the paper to the intersection point. And then I open and fold my bottom edge to the fold that I just made. And here I would feel a bit more comfortable if I bring that first fold up as a mountain and bring it to the central intersection, because I do have that point-to-point reference, but I'm still going to rotate around and fold my formerly top edge up to divide 6 in half to make 3 to get a line all the way across before I return back to my previous orientation. Bring that first fold that I made on this direction up as a mountain and bring it to the fold that I just put through the target intersection. And whenever I have this narrowest division that I'm making, I'm more cautious about my reference points because it's easier to get skewed off, because these 2 points are not as far away from each other as these two, and therefore the error in precision of matching them up to each other is going to cause more error in the angle of the fold compared to a point further away. So then I've got these 3 spacings up top, and I'm going to rotate around so I can fold my edge in 4 spacings. And with each of these folds, I can double check that I've gotten it right, because I will have an intersection of a vertical and a horizontal with my diagonal that goes all the way through. Not the other diagonal. That won't intersect with anything, or it won't intersect with any other grid intersections, but this diagonal that goes all the way through will intersect with each grid intersection it crosses. And then I can fold my bottom edge up to meet that last fold that I made. And so if I was folding more grid on this, I would then start my divisions of 2, and hopefully I wouldn't have chosen a final target that has more odd divisions in addition to a division of 7. And I would also be reversing all of my creases to get them into a neutral orientation. So that was 7th. Let's see another example with thirds. And while I'm doing the thirds, go ahead and drop in the chat some other example that you'd like to see. And I'm going to be doing fifths on the rotated grid. So if there's some other number that you want to see other than sevenths, thirds, fifths, let me know, and then I'll do that after the thirds. Okay, so thirds. 3 is equal to, what's the power of 2 that's the first power of 2 that's less than 3, that would be 2, with 1 remaining. So if the bottom edge is 2, then I need to find exactly halfway across the top. So I fold in half, make a pinch, so now my 2 and my 1 are in the paper. Now I need my 2 diagonals, and I'm going to target their intersection. I know they're going to intersect more or less here. And so when I fold, I'm going to pinch. I'm going to make sure my fold is actually going corner to corner, and I'm going to pinch just in the area that I expect that next diagonal to come through. Then I'm going to set up the diagonal in the other direction. Going to my pinch mark halfway across the paper. And in this direction, I can see exactly where the other diagonal goes through, so I can make a very small pinch. I'll mark those so you can see as well. And with that reference intersection in place, now I have 1 above and 2 below, because we did 1 above and 2 below. And then I'll fold my bottom edge up to meet my reference intersection. This is the only time that I'm going to do a line to a point, but I have the edges of the paper to help keep me parallel. And right now I'm not seeing any suggestions of other divisions to work on. Just throw out some random numbers. We've got I know people are watching. Got to get a number to get that next example going. So once I had the bottom 2 folded in half, that made 1 below and 2 above, which I folded in half. Then in the other direction, the same exact way. So we've got the larger space, which is real easy to tell with 1 and 2. It was a little bit harder to tell with 3 and 4. And once again, I've got this line that's already folded in my paper that shows me exactly what point should line up with the reference point. And yeah, so there's a question, want to do something like 3 to 5. I'm not entirely clear on what you mean. For my folding, I do divisions of 3, 5, and sometimes 7. Usually not in the same piece. But if I wanted to do, say, a division of 15, then I would want to have a division of 3 and then move on to a division of 5. So I've got my division of 3, and I'm going to go ahead and reverse the other direction as well. And so if I, say, wanted to fold a division of 15, then, okay, so the question is a division of 3 in one direction and 5 in another direction. I haven't played with irregular grids like that, but we could do something interesting with that. So let's say I did want to divide this paper then into 15. I would start with the smaller factor, the 3, and then move on to the 5. So let's say I actually do want to do that, and we'll do that as our example instead of the other one. Yeah, so if I want a division of 30, they're saying it would be easier to go with 32 and cut 2, or you could do 15 and then divide by 2. So let's say we do want to get to 30. We've got a good starting point here already. And let's say I want to then divide these by 5. Okay. So if we have this, what I'm going to say is, okay, I already have 3 across the bottom. I have these 3. And I'll go ahead and mark my edges on all of these folds. And so once we have thirds, we're already in the perfect position to then go ahead and divide in 5. Because what we have here is 3 divisions on the bottom, and we have that same measure on each of these 3 lines. So what I'm going to suggest is that we actually pick a slightly different trapezoid, and this will mimic using rectangular paper, the other question that came up. So what I'm going to suggest that we use our second grid line as if it were the top of the paper. So with this, we have 2 spaces here and 3 spaces down here. And I'm going to get a division this way and a division that way. Now I could have chosen these slightly differently, and I think I will do that so we can reuse a diagonal. I'm going to pick our target intersection from the last one. So we've got 2 over here and 3 on the bottom. Now we already have that diagonal, and we're going to get the 3 going across. Now I need to emphasize this diagonal in this area so I can get the full effect. But that's easy enough since it was the diagonal I'd already started using. So I need it in here, and then opening up, I'm going to put a diagonal from my bottom left corner to this point here. So I'm reusing one of my diagonals from earlier, going up here and pinching where I cross the previous diagonal. Okay, so what I just did, and I'll draw this on, I had 2 and 3. Well, that's not following the rule that I said earlier, where I had to have the highest power of 2 that's less than my target number, which would be 4 and 1. But that was really just so I could get the easy reference on the top edge. This works with any 2 numbers that add to my target division. So my new target intersection is here. And I know, because 2's on top and 3's on the bottom, that this corresponds to 2 and 3 in this 2 spacings. So we've got 2 grid spacings, and I want to divide each of them in fifths. So we could think of this as 2 and 3, or we could think of it as 4 and 6. So what I'm going to do first, because 6 is the bigger number and they're both even, I'm going to do the bigger number first and bring my bottom edge up to that reference intersection, making sure that my edges are lining up, fold all the way through. I have a few more reference points here where my initial divisions are lining up with their through-going lines. And then opening up, now I have 3 on the bottom, and I've got 2 to the next grid line, those thirds that I had already put in, and 1 more to my target intersection. So that 2 is a really juicy target, so I'm going to rotate around to my preferred orientation, folding away from me, bringing that grid line to the fold that I just made. Because once I fold that, then I've got a 4 relative to my bottom edge. And so I made that fold, and I'm going to rotate back around. I'm going to use red to mark my new divisions. And then I can bring my bottom edge up to that 4 line. And I'm targeting getting all of my fifths into the division on the edge. So that was a 2 because I brought it to the 4. And I can bring my bottom edge up once again. And open, and I'll mark those 2 lines. So now we have a slightly different topic, which is propagating odd divisions, not just making odd divisions. We've got the fifths in this section. How do we get them in the rest? So I'm going to rotate around, and I'm going to target the line that goes through our target intersection. So I know that there's 4 spaces to it, and I need 4 spaces after it. And what this comes down to is, if I was folding this grid line, I would be bringing this line, this lower third, all the way up to the edge of the paper. But in order to fold 1 new division below, I need to come down 2 new divisions from the top. So I'm going to pick up that line, come up to 2 divisions below the top, and we can verify this because our initial split with our reference intersection was 4 and 6. So in order to go 4 above the reference intersection, we need to come 2 fewer than the whole space, and lo and behold, it goes straight through. So that technique of back off 2 new spacings to get a fold 1 spacing lower is what I'm going to use for the rest of the folding. So I'm going to back off 2 more spaces to put in the next line. I'm going to back off 2 more spaces, which puts me at the target intersection to get the next line. I'm going to back off 2 more spaces, which puts me folding to the line that I just made. And if I tried to back off 2 more spaces, I would be folding that line to itself, which I cannot do because I can't fold 0 distance. And so instead of doing that, I'm going to jump back to the next grid line and fold it up, theoretically, not necessarily literally, on that line that I was going to fold, and then back it up 2 spaces. And keep backing it up 2 spaces at a time until I've folded all of my divisions. And back that up. Now we cross one of the original grid lines. So with fifths, the pattern is 2 below the top, 4 below the top, which is 1 above the next, then 1 below the neighboring large grid line, then the smallest division is 3 below the neighboring large grid line. And so I'm mentally keeping tabs on which lines were there already, the ones with the blue markings, and which ones were not, the ones without markings or with red markings. And once I've done that, I'll flip my paper over and reverse the new creases, which is do 4, then skip 1, then do 4. Until I'm all the way across. And then I want to do this in the other direction as well. Okay, so for doing this in the other direction, one of the benefits of using this main diagonal is that I'm guaranteed that this will be a grid intersection. Our target reference will be a grid intersection in the other direction as well. And it's going to be the same distance as it was from this edge. So it's going to be 6 in this direction. But I don't have to rely on that. Even if I had chosen the other 2 spacings for my 2 and 3, I would still have a similar relationship. I would just need to justify it another way. And that justification is that this edge is a grid line. So we've got our 2 and our 3, and one of the edges between the 2 and the 3, so this edge and this edge, one of them is a grid line, and therefore the intersection of diagonals will be at a grid intersection. And I proved this with fancy math, but there we go. And there's a question, is there ever a situation where you really need a division of 15, where 16 isn't good enough? And I would say yes. In my experience, So there's two situations. One of them is figurative models with box pleating. And the other one is if you're being really specific about about how you're aligning your repeats with the edge of the paper. So there's never a situation in practice piece tessellations where you would need 15 instead of 16. But if you're doing something very specific with your alignment, you're doing a rotated grid, you're folding all the way to the edge, then yes. There definitely are cases where I would very much prefer 60 to 64 or 30 to 32. And so in the other direction, I'm going to do the same thing. Since this is a point at 6, I'm going to fold the bottom edge up to meet it. And I'll move a little bit faster in this direction. Now I can't fold my bottom edge up to the fold that I just made because that's 3, but above it, there's an old grid line that's 2 above the fold. So I'll rotate around, fold that in place. And then I can fold to that line, which was the 4, because we were in half between 3 and 5. And so folding up to the 4, I got the 2, and then folding up to the 2, I get the 1. And then I can rotate around and propagate it through the rest of the piece of the grid. So another reason to fold 15 directly, say for a figurative piece, instead of folding 16 and cutting off an edge, is if you're using a patterned paper. So if you're using harmony paper and it has some kind of pattern emanating from the center, then you're really going to want to keep the paper centered and not cut off part of one edge. So there's a couple situations where you would want to do 15 instead of either 16 and modify or 16 directly. And so I'm going through here, propagating my fifths. Sounds like propagating plants, but got these odd divisions. And coming up to the end. And then I'll demonstrate, and I might change my mind about whether we're doing fifths on the rotated grid, because we just did fifths here, with the rotated grid. And I think I do want to keep using fifths. So if I was using this and continuing on, I would reverse all of my new creases in this direction. But for the purposes of today, we're going to switch over to my rotated grid. So this grid is not aligned with the edge of the paper. The specific grid that I used is 1/3 of the way up the edge. And to find that third, I did use a reference piece that already had divisions on it. So in order to get fifths, I need more grid. I've got 2 spaces and nothing parallel to it. So I definitely need more grid. So radial divisions, that would be another topic for another time. I'm not as familiar with the radial divisions since I'm mostly working with parallel divisions. But I can certainly ask and get back to you in the comments. So to get more divisions, to have enough even spacings to get my fifths going, I need to divide my paper in half in each direction again. So the way that I set up my rotated grids, these places where the grid lines intersect with the edge are by definition grid intersections. So I know that I can bring each of those points into the center. And I'm going to do that in both parallel folds first, then reverse them and do the other set of parallel folds. And bring those into the center as well. Now I have an additional reference point of this line continuing through. I know it's a little bit invisible on camera, but it's something to look for in person. And now I have more of my grid lines. Specifically, and I'll mark where these intersection points are. I've got 4 divisions in one direction, 4 divisions in the other. And getting the rest of these marks in. This may be sufficient to do our odd division in one direction. Actually, yeah, okay. Good. So we have a couple options of how to move forward here. We could take these 4 divisions all the way across, and then any one, and there's going to be another one here, but we don't have the line for it yet. Any one of these, but only this one would have another edge that's a grid line relative to the 4. And so if I was doing 4 and 1, I would want to do this one, and I would need this edge, which is kind of a tough reference, but we're going to go ahead and fold them. The other way would be to do the 3 and 2 that we're already familiar with. So I've got 3 and 2 that share another grid line, and that would be the easier way to move forward from here. And then, and you're welcome, Nancy, happy to help. So for getting these corner lines up, so we're getting a little side discussion about propagating into the corners on rotated grids. What I'm going to do is I've got this grid line coming through. I'll go ahead and draw that more clearly. And I know that this point is a grid intersection. So I need to fold up such that my fold comes exactly to that point, and this line lines up on the top and the bottom. So I'll mark the top of that line as well. And this is really tricky because we're working with a teeny tiny angle here. But we can get it more or less in the right place. And then reverse. And I'll need to do that for all 4 edges eventually, so I may as well do it now. There's not really going to be... Okay, so depending on what your rotation is, there might be some better references in the future. But for our purposes, we're just going to do all 4 of these corners. And then continue onwards. So one more corner. Now we have all of the references that we could want for a variety of different ways to fold fifths on this grid. And so the way that I'm going to do this is going to be using the most stable references I have. So I could do 4 and 1, but I'm going to prefer to do 3 and 2. Again, keeping our 3rd edge. So I don't care about the 4th edge, but the 3rd edge needs to be on a grid line so that this reference also makes sense in the other direction. So with the target points, and I'm going to mark those in blue, our target corners. And we're going all the way out to the edge here. Let the camera refocus. We need to get our diagonals on these 4 points. So that gets a little bit tricky with the rotated grid. I'm going to rotate a little bit so that these points are on the half closer to me, so I can fold away. And I'm going to be very careful about finding my reference. And conveniently for me, it looks like this first diagonal is exactly parallel to the edge of the paper. This is not usually going to be the case. And then I need my pinch more or less here. So pinch happened here. And I'm going to need a second diagonal through here. And here's where marking really helps, because I can actually see these pen marks on the other side of the paper. Got to make sure that I'm going straight through those corners and come over and get that pinch. And if I'm doing a display piece, I would be doing this from the opposite side of the paper so that the harsher marks of my pinch are on the side that I don't consider front. So from here, I've got 2 spacings and 3 spacings. But I also have 5 more that I can use as well. So instead of bringing this line to this point with, frankly, scant reference points to make sure I'm staying parallel, I'm going to choose to take that 3 plus 5. You can always do this with the odd side because you're doing an odd division. So you're going to have an odd number plus an odd number, which is always even. So I'm going to rotate it around, bring up this grid line that's 8 away from my target intersection, and bring that line up to meet it. I want to get really careful about being exactly centered on that target intersection, before I fold all the way across. And I have additional references here in 3 lines that I can see continuing both above and below that need to line up. So that was 8. And so now we can fold the 4 remainder in half. And we can fold the 2 remainder from 4 in half also in half. So the important thing when you're doing odd divisions, when you have many spacings that you're dividing, is to get all of the divisions inside of one spacing, and then you can always use that to propagate elsewhere. So I'm going to rotate around so I can fold away from me. I've got the 1, 3, 4, 5. So I'm going to fold the bottom to the 4 to pick up my missing 2. And then if I choose, I can propagate then in either direction. So I'm going to quickly propagate down this way, then the other way, and then show you how I can use this to get my folds in the other direction as well. So you saw how I propagated fifths already. I won't belabor the point. But it's exactly the same in a rotated grid as it was in the other grid. Each time I'm bringing my mountain back to small spacings to create a new fold, one spacing down. And that makes sense because we're folding in half. So if we want to get one change in the half of something, we need to change it by 2. That last fold went straight through my target intersection. And so even if I didn't have this fold here propagated into the corner, I could still use the fact that the central axis comes to the edge at a grid intersection for all of my rotated grids to use that as a point-to-point reference and get my folds in this division. And I'm still primarily using that as a point-to-point reference. I just happen to also have a bit more information. But that point-to-point reference is still the most trustworthy of all of the references in the corner of the paper. And here I'm seeing there's kind of a ghost line in my division, or I could bring it up at the edge, and I'm going to choose not to until I have better references. And so then I'm going to rotate around, propagate on the other side, again using where the central axis comes to the edge as a point-to-point reference. And next week we'll be back doing this on triangle grids, including rotated triangle grids on hexagons. And flipping over, I'll reverse all of my new creases. This brings all of my creases into a neutral orientation, so I can fold in the other direction, folding across these creases without worrying about the paper curling in one direction or the other. And also so that when I go to fold my tessellation, I don't have to worry about, oh, this line is set in a mountain state or a valley state. Okay, so we got the fifths in one direction, and then there's a couple ways that we can use this next reference point. One way is to say, hey, I trust the math. We set up our 3 and our 2 so that they shared a grid line on the non-parallel direction, and say, therefore, this must be a target intersection. This must be an intersection of the target division. The other way would be to say, hey, I don't trust that reference, and therefore I'm going to fold a diagonal on this grid so I can see where all of my new intersections have to be. So there's ways with trust and without trust. I've done the math on this, and it does work out. And so I know that this was 2 and 3. What the math doesn't tell me, and I could calculate this, but I don't bother to come up with an equation because it becomes very clear, is that this is 1 and 4. You just have to kind of see that for yourself. Or, as I said, you could put in the diagonal going all the way across to get your references for the other direction. Up to you. So now that I know that that is 1 and 4, I'm going to rotate so I can divide that 4 in half. And this time, I don't care as much that I'm folding things that are fairly close together, because I have that line that's going through that I can use to make sure that I'm staying parallel. So if that was 4 and I divided it in half, now I have 2 to divide in half to get a single division. And I'll make sure to drop a link in the description on the math that proves that that has to be a grid intersection in both directions. And then I rotate it around so I could finish the divisions inside of this set of this larger division. And so I'm going to fold up to the 4, folding all the way through, opening, and if I am correct, this will fold exactly through that target intersection. And indeed, it does. So from there, we can propagate like we've seen several times already. And so I'm going to leave it at that. And once we get out into the corner, the thing to look for is, are there any coincidences with the edge of the paper and grid intersections? If there are, we can use those as further references. It doesn't look like there will be in this case, potentially all the way out here, but this is a kind of fussy rotation. So whenever there's rotations, I don't really look for coincidences. Sometimes it happens, and that's nice, but most of the time it doesn't, and I rely on the math. So that is how you do odd grid divisions on squares, whether you're doing them directly on a square to create thirds or fifths or sevenths, and that's all you want, or if that's what you need before doing more divisions of 2 or more odd divisions, as we saw, to get 6, 14, 15, 20, 27, whatever grid division you want. My favorites are 24, 48, 56. So sometimes 40, sometimes 80. And so you can use this technique in a wide variety of ways. You can also use it to find specific reference points. Although for that technique, I do recommend like having a ruled sheet outside unless you're doing that on a rotated basis. I would be really curious if you have any examples of rotated bases for figurative pieces where you need to find specific places, but that would be very interesting to see. So happy folding, everyone. I hope you fold many odd division grids, and I'll see you next week when we talk about the same technique applied to triangle grids. So happy